Good evening, everyone. Thank you very much for inviting me here tonight. It's a great pleasure. It's also a great pleasure to be here in Melbourne. I've been to Australia a few times, but this is the first time I've stayed for nearly a couple of months, and it's really good. I'm enjoying it very much. My talk tonight is about doing statistics with industry and demonstrating the impact from that. As Damien said, I'm Technical Director of the Industrial Statistics Research Unit, this one, ISRU, at Newcastle University. We're an independent unit, self-financing, which is part of the School of Maths and Stats and Physics. I'm going to give you a little bit of context, first of all, to our work with engaging with industry, just to describe the Industrial Statistics Research Unit, talk about this business of impact and how we try to make impact what it actually means, at least to us in the UK, and increasingly in other countries, I think, and relate that to what's called the REF, which is the Research Excellence Framework, at least in the UK. And the way we do this in ISRU is very much through things called knowledge transfer partnerships, which has something akin to linkage grants that you might have in this country. And so I'm going to describe that mechanism, and then give you some case studies from some of the KTPs, as we call them, that I'm working with at the moment. First of all, I like maps, so here's a map. I expect a lot of you have been to the UK. This is Scotland up here, Wales here, and England. London and the southeast is the rich part of England, and Newcastle up here is the depressed, deprived industrial area, suffering from the loss of heavy engineering, mining, shipbuilding, and so on, but consequently pretty innovative in creating small businesses and doing a lot of work to find ways of making a living. And that's where we're based, up here. This is Ireland, and this is Northern Ireland, and this is the subject of the catastrophe that's ongoing with Brexit. It's this border here, this being Europe and the rest potentially not being. So that's where we're up to. A bit of ISRU background. It was set up by a professor of statistics called G. Barry Weatherall way back in 1990 because he had a lot of work with the process industries. He worked with a massive enterprise called ICI, which was located very near Newcastle, and he did a lot of statistical process control, monitoring the output from the chemical processes, which are characterised by having sort of wavering means, which are based on the changes in catalysts and changes in conditions. So it's a different sort of type of process control compared to manufacturing. He also did a lot of designed experiments which helped to improve the output from all these processes. We then moved on to rebadge it, if you like, into Taguchi, because Taguchi came along talking about designed experiments in the context of industry. As you probably know, designed experiments, a lot of the theory was worked out in agriculture, where it takes a year to get a result of your testing your trials, whereas in industry you can get results much more quickly, and so it required a different sort of way of looking at it. And Taguchi, a Japanese engineer, sort of had a different slant on it, which was very popular. This tied in with Six Sigma, which is a quality improvement management initiative, which very much encased statistics in the whole project management circle. So this DMAIC stands for Define, Measure, Analyse, Improve and Control, and the central parts of that are statistical, but for the first time, if you like, the statistics was very much badged under the define aspect. So all projects, instead of just starting straight off with statistical analysis, we were encouraged to really make sure that the analysis we were doing is what the industry actually wanted, is what they intended, before we got started. And this, I think, led to very much an improvement in the way that statisticians engage with industry. We were also very lucky in getting a lot of European contracts that helped us to spread out our influence, if you like, over Europe. One of these is Pro-ENBIS. ENBIS is an association called the European Network of Business and Industrial Statisticians, and we had a European contract and grant to help us set that up. And then finally bringing it up to nowadays, We moved into data mining as data became more sort of prolific and more forefront of people's consciousness. Moved into the service sector, utilities, water, gas, and gas is one of the case studies I want to talk about. Healthcare, a lot of work in the National Health Service, and currently looking at how we can encourage small to medium enterprises, SMEs, to make use of their massive quantities of big data, and that's a very interesting area. So how does that sort of tie in with impact and REF? Well, in 2014, all universities were told that we had to present case studies, and this was somewhat out of the blue and caught a lot of departments on the hop. And it was particularly difficult for mathematics and statistics departments to show the impact of their work. We had to have a case study for every 7 or so academic staff. 20% of our funding was based on that. And as I'll show you in a minute, it's a complicated thing. You have to have publications of a reasonable level over the last 20 years, but impact in the last 7 years. Currently, this is how impact is defined. The next REF is in 2021 in the UK. They're every 7 years. But again, it's something that is spreading around in different countries, and you probably have something similar, but you may have it formalised like this if you're unfortunate. But impact has that complicated definition. The important bit here is that the impact has to be beyond academia. So we have to show how our research has actually benefited society, as opposed to just being useful for the chemists or the biochemists or the physicists or the architects. So it's difficult for mathematics because quite often mathematics and statistics work is useful in medicine, useful in building, construction, manufacturing, but it's harder to show the impact beyond academia. And the current one we're battling with, we have to have documentary evidence of impact in 7 years and papers that go back on a theme for the last 20 years. So these impact things are difficult because they have that complicated requirement. And you need one case study for every 10 academics. So if our department's about 50 academics, so we need 5 of these case studies. Previously, only a few academics were entered into this whole assessment exercise, but now every academic has to go in, which means you need more case studies. And 25% of the funding is now based on it. I hope that gives you a flavour of what it is. It's a requirement to show the impact of our research, and every single school and department in the university has to show this. The last one, 2014, it's all formalised and all public after the event, and we had to put in 3 case studies, one of which is my one, which I want to just explain about. So in 2014, we had 3 impact case studies, which was what we were required to show, and they were all rated between 3 and 4 star. We weren't allowed to know which one was 3 star and which was 4 star, so we just assumed the best, so I'll assume this was a 4 star one. I don't know if it was or not. But my one particularly was talking about data analytics in the gas industry. And this is what it was based on. Here's what they call unaccounted for gas. And this is everything that's left over when you count the amount of gas coming into the UK from the gas fields and gas supplies, and you subtract everything that went out to be used by users. We make allowance for all sorts of things to do with the compressors that push the gas around. We allow for the fact that the measurements are at different temperatures and pressures so that there's adjustments needed. And yet there's still, as you'd expect, a sort of discrepancy. And this is the shape of it. It's a very nice, unstable sort of, jagged graph of unaccounted for gas. And it's always been rocking along a little bit positive, because in the UK they like to keep the pressure such that they err on the side of safety. They're desperate not to have the gas pressure get too low, so that it's always a case that you have pressure slightly more than you actually need. So it's all ticking along quite happily, but then suddenly we had this sort of jump up here. And this is where the gas industry got worried and put a lot of money in to say, well, what's happened? What caused this increase in unaccounted for gas? And the issue is that there's a lot of meters that record the gas coming into the country, and there's a lot of meters that record the gas going out. And they're all owned by different people because the gas is distributed to different owners. And you can't just go to each one and say, can you check your meter? Because they'll make a fuss and it's quite difficult to do, and they want evidence that it probably is them. And so we were quite pleased to apply some nice data analytics to all these inputs and try to sort of tease out mathematically which one is the most likely to be the cause of it. And as it happened, it seemed to be the right choice using data mining sort of techniques. And so they could identify which was the meter most likely to have gone wrong. That gave them evidence to go to that meter owner and ask to have it all checked. And they then found that there was an error, therefore the whole thing can be rectified and the costs can all be allocated correctly, which is important because you need to know who is responsible for what, so that we know what money is available for repairs and for improvements and so on. So that was one part of this case study. An impact case study is only 4 pages of written text, and it has to have all this sort of detail and stuff in it. But once the university administration get hold of it, they write it into all this glowing sort of account, which is something statisticians don't like doing particularly. We do lots of good work all the time, but we don't normally want to sort of make a big thing of it. But for impact case studies, you have to, and so it was all rewritten like this to say it was all so brilliant and everything. Looking at different, so these are the sort of impacts that they say that follows on from it. So the reports provide confidence and aid decisions, help them work out stuff with the regulators, and provide data-based evidence to support negotiations. So that's all impact. And it's all evidenced because the gas company managers write letters and are prepared to say, yes, directly because of the work done by, you know, the name and the unit, we then had this improvement. And so that then counts as a nice case study. So what we have to do, what we have to do for impact, just to finish off with it really, we have to have a cohesive theme. And so we've been looking at data mining in the whole gas industry, looking at monitoring the time series and looking at causes and effects and so on. We have published some work in scientific journals on that theme. We've then had this impact, gathered corroborative letters from the industrial people, and put that all together, and that makes a nice case study. And it's interesting that you have to search around and see what reports you can get, because quite often you can get impact reported on your work from other countries too, which is quite healthy. So how to get it? Why I think it's important for a wider audience is because we're now trying to include the concept of impact in all our research proposals. So when we do a little bit of work with a company or an industry, we make it clear that we will have to have this feedback, and we want to have baseline measurements, we want to be able to evaluate the effect of what we've done. And we also want them to collaborate in publications. And one of the good ways of doing that is through these KTPs. I hope if anyone's unclear with any of that, do ask a question, otherwise I'll carry on. So that's something that I think will happen in other countries. Okay, so one of the mechanisms for doing this is the knowledge transfer partnerships. And just as a little aside, people, when they talk about Newcastle, a lot of them note that our bridge is the same as the Sydney Harbour Bridge. And we always say, oh, our bridge was there first, and other people in Australia say, no, our bridge is the sort of better one and everything. And so I thought I'd better check that out. And it's interesting that it's true that both were designed and built by the same company. The one in Newcastle did open actually earlier, but what is interesting is the difference in size. So the Australians can claim to have the better bridge, if you like, in that it's massive. But it is true, I'm afraid, that it was opened a little bit later. So just to solve that one. Newcastle, incidentally, is at the highest crossing point of the Tyne River, which is about 10 kilometres from the coast. So we have a lovely sandy coastline 10 kilometres from the town centre, and this is some of the bridges that we have over the river. So KTPs, knowledge transfer partnerships, are a mechanism whereby the government, via grant-giving bodies named Innovate UK, but they draw funds from the Engineering and Physical Sciences Research Council, so it's Research Council money, which is given to companies to help meet the cost of employing someone to work on a project for a couple of years. So the university employs a research associate, and it could be at various levels, a graduate of some kind. And the interesting thing is the graduate works in the company all the time, but they're employed by the university. So this is a less risky proposition for the company, because they don't actually have to employ the person. They're employed by the university, but the person works full-time in the company. And the grant meets a large proportion of the costs. For a small company, it's 2/3, and for a big company, it's 50%. It has to be a sound project. Usually it's a couple of years, and it has to be something that will have some new research in and will lead to some publications. This is just a slide from the KTP unit, but what's interesting here is this bit. 84 million currently invested, that's per year, and they reckon that the returns are like 640. So in other words, it's 8 times the return. So the return on investment for the government money is meant to be 8 times. So for the UK as a country, this method of giving out finance is considered to be very important. In Newcastle, we have quite a few of these KTPs, 22. Each one is worth funding of about at least £150,000 to £200,000 over 2 years. Currently, in the Maths and Stats department, where I am, we've got 4 KTPs in those sort of topics. So they're all completely different, but in all cases, they're applying data science, which is a sort of conglomerate of statistics and computing and business knowledge, but it's run from the School of Maths and Statistics and Physics, but looking at how we can make more of the data that's collected from shipping on fuel consumption, look how we can improve how utilities are run, look how we can look at the risk of arrears in social housing, and what we can do with the massive amount of company data in another area, auto parts, after sales. And I'm going to describe them a little more in a minute. So first of all, the utilities. I've flagged a lot of the stuff I do under the title of Monetising Data, because it's all about making use of the data that a company has and that they collect automatically. They have to have it for operational purposes, but they don't always do anything with it. And often companies come to the university and say, you know, I've got this massive data, everyone's talking about data, what can I do with it? And so we enjoy sort of helping them out. And one of the ways that you can do this, of course, is to have a look at their data and combine it with open public data. So in the case of gas, I've been working in gas for about many years, but this particular project, we were looking at a number of areas, and one of them was looking at what we could do with weather reports and socio-economic features. Demand forecasting for domestic gas, it's highly correlated with temperature, because most of the gas is used for central heating and heating in houses. But because all of the way the gas companies are set up, a gas company will have a big, what's called a local distribution zone, and there's only 12 in the country, and so you've got 12 places where temperature is measured. That's historical, and in the UK there's a lot of things that are historical and not optimal, because that's just the way it's always been. And in this particular case, temperature is measured in one location, because you have to have it secure, it has to be audited and so on, and yet because the gas is so temperature sensitive, it would be better to measure it in lots of other places. And so we were just looking at what was the benefit of using more localised temperature readings. And here, these ones are actually publicly available. It's data collected by the Meteorological Office. And we were interested to see what is the variation daily from all these different temperature measurements. And the one that was actually used, I think, was down here. But there, you can see there's quite a wide variation. This is the Yorkshire area, and you've got slightly different temperature at different sides of the country. So comparing a mean local temperature to the reference temperature obviously results in a discrepancy in the forecast gas demand. That's the easy bit, if you like. But what's interesting is you can convert that into pounds. Normally, as statisticians, we just do the analysis and say that's very interesting. But it's, when you're engaging with industry and with businesses, it's important to put money on it. And because there's so much gas sort of floating around, if you predict that there's going to be a certain demand based on the temperature, but the temperature is actually wrong, obviously then your prediction is out, which means that you could be putting more pressure into the pipelines than you need to, or correspondingly you could have too little, and so you have to get gas in a hurry from somewhere else, which is not very efficient either. So just this simple sort of calculation gives an estimated value of 30,000 per day. And to make it impactful, you can multiply that up and get a nice big number, which is million. And once it's got a million in it, the university administrators pick up their ears and say, that's great. So you've got to get to 1 million somehow. So over a year, that's a big amount of money. So that was one sort of outcome from this bit of an analysis, this 2-year project. Another thing that we also did during that project was looking at so that was longitudinal, if you like. That's a sort of time effect. But there's also a regional effect, that gas consumption in local areas is actually highly correlated with socioeconomic features, which is obvious in a way, but on the other hand, sometimes you think that's a bit unfortunate. But socioeconomic features are available right down to the granulation of about 50 households, and that's publicly available data from the Office for National Statistics. So something like occupancy rating, which is how many spare rooms there are, highly correlated with the amount of gas that's used. So this was from company data in a certain area in Scotland, matching that with freely available socioeconomic data, and you get this quite good way of predicting, that you can predict what the use of the gas is likely to be. So just using simple regression, you can show that you can explain over 50% of the variation based on a number of different socioeconomic features. We looked at about 40, and a subset of about seven different dimensions encapsulate most of the variation. These are things to do with the number of cars, the unemployment rate, the usage of gas central heating, and the number of children on average in these areas. And so that improved prediction leads to valuable savings, because when you're planning gas supplies, you then have a bit of an idea of what is going to be needed. You can also use this data to target customers, because you've got all this data matched with the actual use of the gas, so that's a fact, and then you've got all these characteristics, the features that have been collected. And you can use decision trees to identify high and low consumers, low-level consumers, and you can cluster analysis on the data and identify the characteristics of the high and the low users of consumers of gas. We've got consumers there as opposed to demand, because the consumption is actually less than the demand when you've got fuel poverty. So it's a sort of subtle difference. People might want to use more, but they can't afford it necessarily. And we're trying to tease out of this whether you can identify areas where people are actually using less than they should do because of the other characteristics that they've got. So that was quite a useful bit of work. The better prediction leads to reduced pressure and leakage, which is actually a quantifiable measure, and better infrastructure planning and customer targeting. The only trouble with this sort of impact is that it's very good and very sound, but can you get the company whose data we were looking at to actually commit to that and say, yes, the work you've done has helped us to make a difference? And that's the tricky thing. But what you can at least say is that the company used the work and the whole change in focus to set up a new centre of excellence around data, which was a shift in the way that they did things and also resulted in new employees and new income and new profitability. And so that is an impact. So even if often with statistics we help things, but we can't actually get a quantification of what we've done, but we can at least show that they're employing more people in this field, which is a good thing. As a second example, risk of arrears. Social housing is something that we have in all countries, but this is where you have highly regulated rents for houses that for people who haven't got much money and haven't got much choice as to what they can rent. And in our area, there's quite a few of these big estates of social housing. Some social housing providers have hundreds of thousands of properties, and so therefore they outsource the control of the rent collection, repairs, the maintenance to software companies. That software company we've been doing a KTP with, and they have masses of really interesting data that they don't currently do much with. So this was a good knowledge transfer partnership project because it was applying data analytics in a new area. Consequently, quite a lot of time was wasted, if you like, or spent understanding the data, communicating with different people, getting people bought into the idea that they should actually make their data sound, that they should integrate it so that we could analyse it. But having done that, you can then do quite a few interesting things. We can easily evaluate who is a risky person as regards getting into arrears. By looking at the past trajectories of the balance of payments, we can look for patterns, we can match that to socio and demographic features of the different houses, the different tenancies, and we can predict tenancy risk levels. We can then use the massive amount of data to look at the effect of interventions. So if we can see that someone is going into an arrears situation, we can apply, they already apply different interventions, but they don't actually quantify which ones were useful. But now we can do it. And this is just a matrix showing before and after. The 0 are people that aren't in risk of arrears, and before, so no intervention happened. 57% of them stayed in the same position, but some of them strayed into arrears. Down here, these are the people who are really very much high risk and in arrears. So the intervention didn't make much difference to them. But these ones here, the ones who were at a medium risk of going into arrears, are actually quite affected by the interventions, and so they move from one position to another. So we can look to get a feel for which interventions are going to be useful. And that's helpful because it means the companies can tune their work more carefully. We can apply lots of different techniques. This is a random forest prediction where we can predict the arrears of going positive, actually, contrarily, means that they're in arrears. And you can see that this is a typical sort of up and down because these people get into arrears because their money that they're given is too late for the rent to be paid, for example. So you get this cycle of up and down because they are constantly behind with their rent. And we can identify different types of tenants from the pattern of their arrears profiles, and that's quite useful. So we can identify people who are sort of floating along here quite happily, ones that have these sort of jumps and other ones that have got a different sort of shape. And that's very useful to the companies because it means that they can help to understand their tenants better. So this one has quite good impact. Not only does the clients of the software company, they're really impressed by all this sort of visual insight from their data, and they are putting more work onto our company. So there's been a big increase in the staff employed, which is all a good impact. And the better targeting of intervention means that there's less data, money in arrears, which is obviously better for running the tenancies. And they understand their customer base better. So again, we have to make sure that we get the actual figures off the company and make them commit themselves to amounts so that we can claim the benefit of that for our impact case study. Okay, just finally, this one, because these are all different, they're all different subjects, which is fascinating. It's all data. Auto part after sales, anyone know what that is? Yes?
Car crashes.
It could, yes, it could be. Yeah, it's whenever you're buying a part for a car after you've bought it. So if you have a crash or if you have a breakdown, then you look in a catalogue and see which part to buy to replace the exhaust pipe or something or other. Or you take it to a garage and they do that. They look to see which part is appropriate. Only the manufacturer knows which exact part they put in. But if you go to the manufacturer, it costs more. If you just take your car to a garage, they have got to guess which is the closest part. And the parts are made by different suppliers. So every day, millions of people look up, millions of garages and people look up in catalogues for a particular part. So they put their car registration in, the part looked up and the date and the time. So we have, from the car registration, we know how old the car is, and in fact we know what model and make it is. We know what part they're looking up, and we can look out of interest what time of day it is and what if there's seasonality and so on. We can look at invoices for parts ordered. Again, we've got the car part and the number of parts that people look at, and we know whether or not it was the right one or not, and again we have the time and date. So the company we're working with here is just a small company that handles this data and is in a position to extract insight from it and get some benefit from it. And so the insight we're looking at is about the lookups that they have every day, about the returns and rates of return. We can also deduce something about reliability of car parts, and we can look at the market share for different suppliers. So there's a lot of different stakeholders that we can help. And there are just 4 pictures here. This one just shows this is in 2017, this is the age of the car that for the part that was being looked up. So it shows that there's a sort of peak here where the car's about 8 years old. So a car that's 8 years old, that's when things start going wrong and they start to look up for the parts, which is quite interesting. We can look at which parts are returned more often than others, and we've used a funnel plot here because there's different numbers of parts in each of the different numbers of quantities of part for each of the products that are sold. And these, up on this axis, we've got the percentage that are returned, but the control limits depend on the number that were ordered, of course. And the ones in green here are parts that were represent quite a large value for the companies, but there's quite a high return rate, and so they can quickly zoom in on them and prioritise which ones to check out, why there's this high return rate. This is a interesting sort of way of looking at things. When a car comes in to have a part changed, we know the mileage, and so we can sort of turn that on its head and sort of look at that in terms of reliability. And it's interesting that if you look at the mileage for which some different types of car came in, each of these lines is for a different manufacturer, which I won't say which, but these two are very similar, but the blue one is obviously more dodgy. That means that you're coming in with a lower mileage than with the other two, but I can't say which, of course, but it's quite interesting from their data. And then finally, if you look at the market share of a particular supplier, these are for different products, and you can see that this is different. This is oil filters, I think fuel filters, air filters, and cabin filters. And there's a similar pattern in all these, that they've got about 10% of the market share, which is okay, but there's this cluster of particular vehicle types for which they've got a lower market share, and that's something that they can look into. And again, the impact here is that the clients of the software company are attracted by all this visual insight, and so they are putting more money into the company, which, because it's a local company, means they're employing more people, which is a good thing for the UK PLC, if you like. But also, we can just about show that there's efficiency savings, and people can actually save money from replacing parts that are the wrong ones and get to the correct choice much more quickly. So those are my sort of three case studies. They're using sort of rather simple techniques, if you like, but behind them is quite a lot of combining data, and most of these projects I work with are computer scientists, and so there's input from that side as to get the data in the right format, and then a means of analysing it. So statisticians, computer scientists working together, but with a business focus. So that's the three sides of data science, if you like. I actually like all this stuff because it's a career and a hobby for me, combined. And a good example of that is the fun of helping friends. And this is a friend of mine who has a boutique, and she likes collecting data, and she collects every day routinely the number of people that come into her shop and the amount of money she takes. And so we just amused ourselves looking at what you can get from this. And it was quite interesting. The first year of business is sometimes dodgy for a small company, but you can see this is the takings, and it's quite steady. So after a year, through quite difficult setup time, she was pleased that the takings were quite steady. This is the increase in takings for Christmas, which you expect, but also from here you can see when it starts. So it starts quite a few weeks before Christmas, and you get this build-up. So that's when you have to start getting your stock in. There's also a little build-up here, which is Easter, but less so. Here, this is an interesting one. This is the amount of money taken off each customer who comes into the shop on average. And it's interesting that the big one here, this one is quite a bit higher average taking than from this one. And this, of course, is the owner, and this one is someone else. So it could be that the owner is just very much better at getting people to spend money through cross-selling and upselling and all the rest of it. But it's also an interesting sort of teaching slide, because there's other reasons for this, aren't there? That if you were the owner, you would work in the shop when the best prospects were going to come along and have the most income. And you put your assistant in when there's not much happening. So it's not purely their better technique, but I think in this case it probably is. And then down here, we've got this one is the sales per hour. And you can see that on Saturday, you've got the highest sales per hour, and followed by Sunday. But the interesting thing is the sales per customer is fairly steady. So what you could deduce from that is that they have different hours for each day of the week. And the fact that this is flat-ish, although the shop's only open for, say, 5 hours here, whereas it's open for about 10 hours here, the sales per hour are pretty steady, which means they've just about got it right, the opening hours, because there's no point in staying open any longer. And the sales per customer is fairly steady, because people come and look at the produce at the weekend, and then they come back in the week. So, it justifies that you want to be open each day. So lots of nice stuff that you can deduce just from an innocent set of data. She also collected the weather on every day, but we couldn't establish whether people came in when it was raining, or whether they were at the coast when it was sunny, or what. So, but there's lots of stuff you could do and to help it. Just some facilitators, I think. If you want to engage with industry, then you have to network around and sort of get involved in all sorts of things. Currently, I'm working on a thing called cancer engineering, which is quantifying the emotional response of people to new designs of products, so that you can help design the products that people want, but that's to do with quantifying their engagement with the product. But we're also looking at data science for SMEs, And through the MBIS, the European network, we're looking at getting community funding for a project across Europe, which would be good. These are the societies that I'm in, which is the Royal Statistical Society and the Institute of Stats, and it's the International Statistics Institute. This is a charity, Maths in Education and Industry. These two are Institute of Maths and its Applications and the London Mathematical Society. And this one here is the International Conference on Teaching Statistics, an international association, and the one MBIS here. And I think meeting all these different people with different outlooks from different fields is really helpful in getting ideas and meeting people who have projects that we can work on. Just finally, the MBIS thing. We've had great fun with this over the years. It was set up about 20 years ago, and one of the contributors was a lady from Oslo, from a food research institute, and she created this nice beer experiment. And beer is always useful because it's a nice friendly thing to do after a course. And we used to put in this designed experiment after a course, because what she designed was an experiment with just a 2-factorial experiment with 3 factors, but you can obviously think of all sorts of other factors. And the advantage of the factors that we've got here is that it always works. And we're measuring the height of froth on the glass of beer, and you could say that we want it maximised because that's what people like when they see a glass of beer. And we provide 2 different types of beer, like a French and an Italian one, say, or a German one. We have 2 different types of glass, a curved bottom and a flat bottom, and we pour it with a different angle. So we either just throw it in at the top or we pour it at an angle like this. And the advantage of these particular factors is that you always get an answer that's reliable, because you can show the results of the factors. But this is a really nice experiment because you can invite people to think of any factor that affects the height of froth of beer. And you can imagine how you measure the height of froth of beer is an interesting one. Who you get to measure it, how you record it, how you get consistency. I mean, it can go on and on. It's a really good experiment. You could have a simple 2-cubed factorial here, or you could do a Plackett-Berman design, or anything else. You can, arrange your repetitions how you want. Plackett, incidentally, was Professor of Statistics at Newcastle for many years, and he did his Plackett-Berman design in 1946, which is the same designs as Taguchi uses, which is these 4N designs. So this one here is reliable because there's an interaction between the glass and the angle, and this is just using Minitab, the outputs. Doesn't make much difference what beer you have. The type of glass makes a difference, the angle makes a difference, and you've got this interaction. You can use a half-normal plot to identify significant factors. And basically, if you've got a curved bottom of the glass, then it doesn't matter too much if you have it at an angle or you don't. But if you've got a flat bottom, then it makes a big difference. So it's quite a nice experiment. And that's something that we got because we've had this network, which is rather nice. So, in summary, I would say that for statisticians, I think industrial projects are very interesting, and there's no limit to what you could do. Even if you want a really theoretical approach to develop new ideas, to develop new theorems, you could still use that on and check things out on the data that you get from companies. And I think it's a challenging combination of academic excellence potentially and societal impact. Previously, we used to spend our time between teaching, research and admin, but now we're spending it between teaching, research and impact, which of course is better actually, because that's more interesting. So I think it's all good and it's going in the right direction. So I think that's it. Thanks for listening.
Thank you very much, Shirley. This will kick in at some point. Here we go. We have time for questions, so if you have a question, please raise your hand. I'll bring the microphone to you. Oh, we have many questions. Let's start here.
Thanks very much, Shirley. I really enjoyed your presentation. My question is basically about, background knowledge, that you need, to do this sort of work. So if you're going into one of these industries and I guess, you're just sort of treating it as a statistical problem, what sort of, background knowledge about the industry do you need and, to do this work effectively? And also, I guess, is there much value in doing this sort of research with other academics, like, for example, who might specialise in, for example, models of social housing or, antecedents of financial strain and that kind of thing?
Thank you. Yeah, that's a really interesting question. First of all, I think it's good that the KTP model is like a 2-year project, which is really good because it gives you time to absorb into the business that you're dealing with. That's one thing. I think I thought you were going to say how you about these sort of theoretical stats aspects, and I think that's another important point because there's a whole range of statistical methodology that could be used on these things, and I think it's very useful to be part of a university so that a university department so that we have colleagues who are specialists in lots of different types of mathematics and statistics. And I think the companies realise that that's an advantage, and so they might prefer to come to a university consultancy as opposed to a freelance consultancy because we've got access directly to experts. So that's that aspect. But talking about linking up with other departments in a university, that's an interesting one. It's true with the social housing. Yeah, I mean, you could get a massive views about which type of people are going to go into arrears. So you could get a lot of background information from that. Sometimes we do team up with experts. Sometimes I think that would sort of confuse it a little bit in a sense because there's been a lot of research on the psychological aspects of which people don't pay rent or are delinquent in some way. But I think this is a new approach by looking at the data. So, in a sense, it's possibly okay to carry on with that separation. On the other hand, for example, the shipping work, I'm working with experts in nautical science, and so they're the experts in the shipping. So sometimes we do team up with subject experts and sometimes not. So I think it's a good point. I mean, the point about all these things is you've got to get an answer, of course. So that's important. We can't spend too long sort of researching it too widely, I think.
There was a question here.
Does your group do much in the way of data mining? I ask the question because how do you go about deciding what's worth investigating statistically? I mean, is it more a human intuition, hit and miss, or do you do it more systematically, say with data mining, to discover things that maybe with the intuitive approach you might have missed because they're so surprising?
There's two sides to that, I think. Sometimes there are specific questions that a company's got that they know is missing and that they would like. So they might need to do something about the increasing arrears that people have got, and therefore they want to have some. So we know that we've got to get some models for the way people's rent balances go and cluster them and all that sort of thing. At other times, we've got a free hand. What insight could there be with the auto parts data? There isn't really any sort of question particularly. There's just this massive data. How can we get added value from it? So you can do whatever we like. And so whatever sort of springs to mind, we just do, because anything is better than nothing. So obviously it's better if there's a motivation and there's someone who actually wants the answer and wants to learn from you. Is that the right sort of what you're thinking of? I mean, for example, with the gas, you have all these sort of time series of meter readings, and we want to identify ones that have got a pattern that are related to the unaccounted for gas, and so therefore you're looking for a specific thing in that. So I would say we do data mining, looking for specific things, and we read up what other people have done in this such circumstance, and we try those methods. There was one up there, I think.
Yeah, hi. This probably leads in well off the last question. As a data engineer and statisticians, we know there's a lot of data and a lot of value we can add. But you're having to sell this to business, and sometimes they're in their, particularly the bigger businesses, they're caught up in their own process. Everything's a lot faster these days. So I'm sort of interested in the marketing side of it and how you get the businesses on side to actually undertake the sort of thing you're doing.
Well, it's interesting, see, because there's such a lot of stuff in all the trade magazines, people are actually coming to us. It's not a question of us pushing it out to companies. They actually approach us all the time because they read about it. Part of our publications, but most of it has to be in scientific, peer-reviewed publications, but we also use the trade press, and we put out stuff that we're doing, and you'll find that there's other consultants sort of putting in articles showing what they've done with data, and that means that makes the companies think that they'd like to do that. So quite often they're saying, oh, this competitor's done such and thing, can we try it? So they actually want it. But of course, the fact that they're going to get funding is very important, except that one of the colleagues I spoke to here in Melbourne was saying that companies often don't want to use something like a linkage grant because it takes too long. It's like a 2-year or 1 year. And so there are some companies that aren't willing to spend that sort of time. But if they are willing to spend that time, and the aim is to embed the person that they get working for them, they actually become an employee after the end of the project. So they're getting a new person, but they're also getting this financial support. I suppose that the situation in Newcastle is slightly interesting because it's difficult to attract skilled people to work there because everyone wants to work in London. And so it's a good way for a company to attract someone. And then once they've worked for them for 2 years, they're quite likely to want to stay because they realise it's interesting and so on. So it's a good way of recruiting. So at the moment, it's more they're asking us rather than us having to push it.
Is that a newer trend, or has that been around for a while now?
It's always been that sort of case. But I would say in the last, over the last years, because data's become so topical, people are coming more and more towards us. There's a chap up.
Yes, so there's a few questions I want to get to all of you. So there's one there, one here. Anyone else? One there. Okay, I'll just start with up here.
Hi, I'm just doing starting my master's, so I'm not so expert in terms of statistics. We all talk about understand the fundamentals and stuff. Are there do the fundamentals have a big impact on the insight you start to get, or is it a lot more specific to each case and you have to use exotic kinds of analysis methods and stuff? You know what I mean? So.
I would say that the fundamentals are really important, and in fact that's what the value added is, because a lot of people can come in and sort of throw stuff into a black box or into one of these algorithms and just take out what comes. But we focus very much on the fundamentals of the quality of the data and the measurement level and all that sort of thing. So I think that's very important, actually. So, yeah, it is important. You must learn it.
So you mentioned that for the research assessment exercise, you need to demonstrate publications in the literature, and you mentioned papers a few times. So I just want to probe that a little bit, because it does seem to me that a lot of the stuff, you can be really useful in industry without actually being at the forefront of research. So how do you get those publications? And the second thing is about intellectual property. And quite often companies don't seem to want you to publish. So do you have an approach to that?
Well, just thinking about the second thing first, respectable companies, if you like, or the institutes, for example, the nuclear industry, one of our impact case studies, they wouldn't want to publish because of the confidentiality and the sensitivity around it. But we are allowed to use reports that are, the company would be willing to divulge it for the purpose of the ref only. So sometimes we can use companies' sensitive reports and it's counted. So it doesn't have to be publicly available if the quality is good, and the quality is judged by peer, a panel of statisticians, professors across the country sort of thing. So you can get around that. If you're talking about a sort of lower level, like this small company that handles the rent arrears and so on, it is a little bit of a problem because they use the excuse almost of confidentiality to stop you publishing things all the time. And I think that's a bit of a problem. I'm not quite sure how we're going to get around that one. The actual concept of publishing is a really difficult one because, as you can see, I mean, this is a paper that probably will count. It's in Quality of Reliability, Journal of Quality and Reliability Engineering International. I mean, that's probably 2-star, so that will sort of count. But it's not going to be, it's very difficult to get 3, 4 or 5-star publications that, are going straight into impact. But it's just something that you have to work towards. And the other way of doing it is to team up with experts so that you use a little bit of theory that someone published. For example, Professor Murray Aitken had a paper, he's well known to some of you here, that had mentioned a technique that was tried in one of the case studies. And so you sort of add that in as one of your bits of evidence. So wherever you can, you have to do that. But you're only allowed to choose about 5 papers. So you've got to try and get 5. And worse than that, they've all got to be in the unit of assessment that you're being assessed in. So if it's statistics and maths, it's got to be stats and maths journals. So you can't have a brilliant publication, if one were to have it, in the oil technology journal, even though that's a 5-star oil technology. It's got to be a stats journal. So it's difficult.
Thanks for the talk. It was really interesting. I was just wondering, if you had to buy a car, what brand would you buy?
Yeah, well, there's a good point, isn't it? I would know, though.
So we're coming towards the end. So if you have any further questions, you can come and talk to Shirley afterwards. But I might end with one more question. Take the... So you've mentioned that data visualization is one of the ways you've added value in many areas. Do you or have you planned to hire a graphic designer as part of your team to really bolster that aspect?
It's a good point, and we should do, really. I mean, we should employ writers and graphic designers as well. We should do, and maybe in the future we will. These teams that do the KTPs, sometimes I'm the sole academic supervisor. Currently, I'm pairing up with a chap who's a professor in computer science. But in another one, there's people from business school as well, and we could have someone who was good at writing up and presenting or graphical visualization. So, yeah, it's a good idea.
So on that note, I'd like everyone to thank Shirley for a wonderful talk today.